Welcome to P. Clark Calc, where we do practical calculus for the busy math student. And today we're going to take a look at kind of an oddball case of infinite series known as a telescopic series and how you can actually calculate the sum of that infinite series. So let's see how that's done now. Here we're looking to sum the infinite series 3 divided by n times n plus 3 as n goes from 1 to infinity. And the trick that we're going to use to do that, a neat trick called a telescopic series, which requires us to have a series written as a difference of two rational expressions. Here we have it written as 1 over a n plus b minus 1 over a n plus c. And the key to understanding if that's telescopic or not is to look at the quantity c minus b, the difference in the constant terms, divided by a, the coefficient of the n variable in the series, and that needs to be a natural number. So a natural number means integers starting at 1. So if that doesn't happen, then it's not going to be able to be summed. If it does happen, it's called telescopic because when you write out the expanded form, you see that most of the terms cancel and it leaves a small number of terms that you sum manually, and that will give you the answer. And the number of terms that you need is that c minus b over a quantity that we determined before. So the problem here is that it does not look like it fits the form. Here we have 3 divided by 2 factors in our series, and how am I going to express it in a way that's the difference of two rational expressions? And the answer there is the partial fraction decomposition, which states that the fraction 3 divided by n times n plus 3 has a general form of a over n plus b over n plus 3. You make one partial fraction for each of your distinct linear factors in the denominator. And then we go ahead and we multiply both sides by the LCD, the original denominator, to get what we call the basic equation. 3 equals a times n plus 3 plus b times n. So that's the equation that is true for all n, but we want to pick two nice values here. The ones we use are the ones that zero out the factors of n. So for instance, if we let n equal negative 3, the equation that we get is 3 equals negative 3b, so b is minus 1. And then if we let n equal 0, the equation is 3 equals 3a, so a equals 1. So this distinct linear factor case is some of the easier partial fraction decompositions that we encounter. And so then when we rewrite the series that way, we see that in fact that this is going to be telescopic. We have the summation from 1 to infinity of a, which is 1 over n, and then plus b, so b is minus 1, so it's going to be minus 1 over n plus 3. So that's indicating to us now that we can find the sum because it appears to be telescopic. We have the difference of two rational expressions, but before we move any further, we want to do a calculation on the terms needed and make sure that c minus b over a is a natural number, which it is. So here we have 3 minus 0 divided by 1, which says 3. It tells us that it's telescopic, and also how many terms we need to write. So when we go to find the sum now, we just start writing the expanded form of this series. So in n equals 1, my term is going to be 1 over 1 minus 1 over 4. So 1 minus 1/4 is the first term. And then the next term, when n is 2, will be 1/2 minus 1/5. And then when n equals 3, we have 1/3 minus 1/6. Now that continues to infinity, which if you just would write it out to begin with, you'd say, well, I'm not sure if I could find the sum. But we typically would not write any more once we understand how to do this, but let's just show a couple more terms here The ones in red we would not typically write. But the next term here would be 1/4 minus 1/7. And then 1/5 minus 1/8, and so on. And so as soon as you start seeing this occur, if we go back, here's why it's called telescopic. This plus 1/4 of the fourth term is canceling with the minus 1/4 in the first term. And the 1/5 in the next term cancels with this 1/5. And the next term would cancel the 1/6 from here. Now, as far as the second term in these other terms of the series that are written in red, what happens, they end up canceling with terms that occur at the end of the series. Because you have to, although we can't write the last term, at some point we're going to end up with 1 over n minus 1 over n minus 3. So these terms, as n goes to infinity, they end up all canceling out as well. So the only thing that results, the only thing that survives this telescopic series as we go to infinity are the first term of the first 3 terms of the series. So the front end of the first 3 terms of the series are all that are going to survive this whole telescoping process. Everything else is going to cancel out. And so we can go ahead then and come up with the exact sum of the infinite series, which is not always possible. And we find out that that sum is equal to 1 plus 1/2 plus 1/3. And if you want to write it as an improper fraction, we can do a little arithmetic here. And we see that the final sum is 11/6 for this particular telescopic series. So kind of a good example. Some of the cases you run into, it might already appear to be telescopic when it's first written, but the case here where you have a constant divided by 2 linear factors is oftentimes telescopic, oftentimes not, but you want to take a look at it anyway and see if possible, can I find the sum that way. And the key is, when you have it expanded out, is to see if that c minus b over a quantity is a natural number. If it's not, you can stop, because you're not going to be able to find the sum at all this way. Here at P. Clark Calc, we do practical calculus for the busy math students. But if you want to dig a little deeper and learn more about telescopic series or infinite series in general, you can find more on my textbooks, which are available on Amazon for a really nice price. So until next time, I'm P. Clark.